All right, folks, we're starting with Faraday's Law today. Faraday's Law basically is how we generate electricity. So incredibly useful stuff. Faraday's Law of Induction, I'm just going to give you a conceptual overview of all this stuff. The basic idea is that you can create electric fields with a changing magnetic field, specifically a changing magnetic flux. Actually, you don't have to even change the field as long as you change something that could change the flux. Like, what could you change besides the magnetic field to change the flux, the magnetic flux? You could change the area, or you could change one other thing. Hint, B dot dA, the angle. You could change the angle too. And that's how a generator works, by changing the angle. You can, if you create an electric field, that means you're creating an EMF. EMF is just the integral of the electric field times the little dl, the tiny length. Really, in its extreme form of a uniform field, the EMF, or really its voltage, we'll see what EMF is just delta V is negative ed. It's the same thing. It's the E field times the distance, and it's typically a dot product, and it's no exception in this case. We get a B field, an EMF, electromotive force. Again, measured in what units is electromotive force measured in? Volts. It's not a force. It is just like a battery supplying a voltage. You can also produce a current. A changing magnetic flux doesn't have to produce a current, but it can. That's one thing to make sure you understand. It always produces an electric field. It always produces an EMF. It will produce a current if there is what present? Electric field ain't enough to produce a current. Electric field, if there is an electric field, there is a voltage difference guaranteed, but there's not always a current. What do you need to have a current happen? Something for it to flow through, like a conductor, and it's got to be a complete loop of a conductor. Faraday's Law will complete Maxwell's equations, so today we are going to actually get to the end of Maxwell's equations. We'll have all of them available here. So this is the actual setup that Faraday used. So he had a galvanometer over here, and he wrapped the coil. This is insulated wire, so there's no electricity going into this from the battery. It's completely insulated right there. And he had another circuit over here, completely insulated. All that, they're just sharing an iron core to help the magnetic field pass through both coils well. Faraday knew that a constant current created a constant magnetic field, so he was suspecting that a constant magnetic field would create a constant current, but he found that that just didn't happen. What he did find was that when he closed the switch, he got a spike of current. When he opened the switch, he got a spike of current. So that is Faraday's iron ring coil apparatus that helped him figure out Faraday's Law. Only when the magnetic field is changing do you get any current, hence do you get any EMF or electric field. EMF, we use this curly E for that. There's an EMF, i.e. an electric field produced by changing a magnetic field. And to be more specific, really you can change the magnetic flux in any way and you will get an EMF. This right here is the most basic form of Faraday's Law. Right here is this. The EMF is the negative rate of change of the magnetic flux, the time rate of change of magnetic flux. So EMF is negative d phi b dt. If you're taking the algebra-based course, we can only find the average EMF, which is negative delta phi b over delta t. The EMF induced in a circuit, it's always in a circuit, is proportional to the time rate of change of the magnetic flux that passes through that circuit. Now, there's an interesting thing if you have more than one loop in a coil. This is true for one single loop of wire, or even just a loop in space. This will be true. What happens if I have one loop, and then right after it I have another loop, and right after that I have another loop, and in each one and let's say there are n total loops, if each one I get this much EMF, what will happen if I have n loops in series that are all experiencing the same change in flux? What happens when you put batteries in series? What happens to the total voltage drop that you get? They add. If there are n loops, what is the EMF going to be produced by a coil of n loops? Go ahead and make that prediction. Okay, so if you have n loops, notice that is just the total EMF of your coil is just n times what we had before, because all those coils are in series. So it's just like batteries in series, they just add up. The EMF is negative n, the number of coils, or the number of turns, either way you want to talk about it, times d phi b dt. Or EMF average equals negative n times delta phi b over delta t.